before making any further update. So now what do you have in the stack? You have plus, you have E input. What you have in input, you have I. Fine. So what is our task? Our task is to complete all the input. Do not stop until and unless all input are consumed. Very important. And there should not be a single element available in stack. That's another very important condition needs to be fulfilled while you are performing any particular type of parsing operation. So far in shift reduce parsing, what exactly we're doing over here, we need to take care of all those parameters. Whether all input being and whether all input we have already shifted to the stack, followed by that whether you have updated the tree, immediately next to that whether you have performed shift as well as the corresponding reduce operation. Let's proceed further. We'd like to see that what happened immediately after that. Fine. So once you will reach to that specific level, now you yourself can tell also that what operation we can perform over here. So while doing this, we do not have any adequate reduce operation. We do not have any reduce operation, then obviously you have to follow the next shift operation, and we did the same. Correct. So try to get the strategy behind the shift and reduce. So while you start performing shift and reduce, this is what is expected. This is the way basically we perform the shift and reduce operation. Obviously, we have to start with shift, and immediately next to that, we need to look that whether we can perform any reduce operation or not. That's really very, very important in this particular context. So while you perform this particular type of operation, so ultimately now you do not have any input symbol left, but in stack you need to perform some operation, because in stack you have I plus E, which has already been shifted to the stack. Okay, so obviously now what we have to perform, we do not have any option, but rather than to perform the reduce operation. Okay, because nothing is available to do any shift operation. All input symbols have already shifted. So now there are a lot of production rules available. Just keep on checking which production rule to be utilized to perform the next reduce operation. So we have selected the following production rule: T producing I, and if we do it, we have the following production T plus E, and using the same strategy, we have updated the tree. See now where we have kept the T is become the parent of I. So if you consider it the same strategy we have applied. Fine. So now you have the stack in T plus E. So you know now what exactly we need to perform. Obviously, this is the reduce rule we have to apply every time. Keep on track on the stack, and then we can perform the following operation. So now what you have done, you have E producing E plus T. So once you have E producing E plus T, so ultimately what is happening over here, we have updated the tree structure, E plus T being reduced with the help of E. And ultimately, if we move further, so we have the last rule available in the following manner, that S producing E, and we did the same over here. So once you're doing that S producing D, so ultimately this is the last diagram available with you, that completed the derivation of stack. So nothing is available in the stack as of now, and we have completed the corresponding tree structure. Okay, so I want everyone to complete the operations as it is given over here. So every stages are playing a very, very important role. So if you go back and if you check also, as every stage being given to you, take your time and do it. Okay, because this is one of the fundamental problem with the shift reduce parsing strategy, what exactly we are doing over here. Okay, so it's very important for all of you to update your class observation file, but before that, please understand in your own way where you're performing shift, where you're performing reduce, how you are shifting the element from input to stack, how you are updating the tree. Those things are very, very important because in every stage there is an update in the stack, there is an update in the tree. Every stage there is either shift or a reduce operation. And all the operations are coming from the production rule. You are not discovering any operation. Please understand that. While you're performing any shift, the symbol itself is available. When you're performing the reduce, that is also available. So you are simply searching and performing shift and reduce operation. Okay, it's nothing innovative or you are imaginary that you are thinking and you are bringing certain new concept into the picture. Everything is well defined, it's well structured. Simply you are finding from the production rule, applying the rule and solving the problem. Okay, so understand the strategy so that any problem you can solve with the same strategy using shift and the reduce operation. Okay, so all of you please complete this, and this is obviously one of the most important problem of this particular lesson, that how to perform shift operation and how to perform the corresponding reduce operation as applicable over here. So just go to the last stage and complete the operation where you have reduced. Okay, so this is how you need to proceed. Okay, so take 5 minutes time and complete the task. That's very, very important over here. So, anyone having any problem as of now? Have you resolved the problem? Please complete. No, that's what I told you. That once you are working with the structure, make sure that you have recognized four very important components of the context-free grammar: V, T, P, and S. And one of the most important component, a certain production rule associated with the staff. So we are not considering that at the beginning. We are considering all production rules for reduce operation except the production rule involved the starting stage. Fine. So this always you have to keep in mind while we are performing an operation, because here our operation is top down. So sorry, here our operation we are starting from bottom and moving towards the root, bottom up approach. Correct. So in bottom up approach, always you have to start with leaf. You have to move towards the intermediate nodes, reaching towards the root. Okay. So this is equally important for everyone to follow the strategy for the shift reduce parsing technique. Now, immediately next to that, we'll be learning another parsing technique that is also a shift reduce parsing technique, but here we will not use the tree structure. Even without using tree structure also, you can perform the shift reduce parsing technique, which is comparatively a faster way of parsing the corresponding input stream. Okay, let's have a look on the next problem statement, which is almost similar to the previous one. Little bit difference you will be getting. Okay, so let me continue with the next problem statement. I believe everyone has completed the previous one, what we already did. Okay,